Let's talk about the t-test for dependent samples. We're going to do it in the context of an experiment to find out if you can improve the number of free throws you make by just visualizing making free throws instead of actually getting out on the basketball court. In fact, there was such a study that someone has done, and unfortunately I've never been able to find the original because I would love to read it. Here's our method. We're going to take the people, we're going to measure how many free throws they make out of 100 before we train them. Then we're going to give them the visualization training and measure how many they make afterwards. For each person, we're going to subtract the after score minus the before score to figure out what the improvement is, and then get the mean for all of those differences for all of our participants. The null hypothesis, which is the one that we use for doing statistical tests, H sub 0, says training makes no difference. There should be no difference in the means between the before and after. In other words, the average of all of our differences should come out to 0. We also want to form an alternative hypothesis. The alternative hypothesis depends on what our viewpoint is. If we're simply trying to find out if the visualization improves performance, and never mind whether it might hurt it or not, but if it does an improvement, then we have a one-tailed test. Our alternative hypothesis is that the mean difference after the training is going to be positive. In other words, people are going to generally improve. If we're not sure whether it works or not, and we're asking whether it helps or hinders our performance, then we have a two-tailed test, and our alternative hypothesis is that the mean difference after training is just not 0. Either they're going to get better or they're going to get worse, and we don't know which. So when you make your alternative hypothesis, this tells you whether you want a one-tailed test or a two-tailed test. What we're going to use to determine whether the null hypothesis should be retained or rejected is this formula, the t-test for repeated measures. The greater the value of this statistic, the more likely we are to reject the null hypothesis. So we're going to look at this d bar, the means of the differences, the standard deviation of the differences, and the number of people. All of these work together to get the t-statistic. What I'm going to do in the next part of the video is not a rigorous mathematical proof. I'm just going to show you how these are all connected and why this formula makes sense.